There is a very strange object flying past our sun. We don't exactly know what this thing is or what it's doing. We can't even see it anymore. But we have been watching this object very closely for months. We've given it a name, 3I Atlas, and we've given it a title, Interstellar Comet. There is a lot that we know about this new visitor to our solar system. In just 4 months, there have been nearly 100 research papers published on 3I Atlas, and there is plenty of other information out there that doesn't appear on the official record. Some of it can sound pretty insane. So today we're going to cut through the noise, and we are getting to the bottom of everything you actually need to know about 3I Atlas. Let's talk about the journey of this interstellar object. Right now, 3I Atlas is making its closest approach to the sun. We call this phase Perihelion, and the peak occurs on October 29th, when the object will pass within about 210 million kilometers of our star. Although in space we typically use a larger form of measurement, that's the astronomical unit, or AU. 1 AU represents the average distance between the Earth and the Sun, which helps us to bring a familiar sense of scale to the vastness of the solar system. So the perihelion of 3I Atlas occurs at 1.4 astronomical units away from the Sun, which means it doesn't actually get that close. It's somewhere just inside the orbit of Mars. But this will be the time of peak activity for 3I Atlas. This is the hottest that it will get, which means that a lot of material from the surface of the object is going to get blasted out into space. Now, that's normal for a comet. We call this process sublimation. It's what happens when a solid material transitions directly into a gas, because there's no liquid in the vacuum of space. And sublimation is what gives a comet its distinct look, with a fuzzy halo and a long tail. The halo is made of all the gas and dust being ejected from the hard surface of the object. It's technically known as the coma. The tail is created by solar wind. That's a name for the waves of radiation that constantly flow from the surface of the sun. This wind blows back all of the lightest bits of dust and gas from the coma and pushes it away from the comet. It's a spectacular piece of cosmic ballet. And unfortunately, we don't get to see this happening to 3 Atlas as it flies through its peak exposure to the sun, because we are on the wrong side. Call it fate or call it something else. Our view of the perihelion is completely blocked out by the glare of the sun. Okay, so we know where 3I Atlas is right now, and we have a pretty good idea of what it's doing. So while we wait for it to reappear on the other side, that gives us an opportunity to investigate how it got here in the first place. And this is a deeply fascinating story. We have been tracking 3I Atlas since July 2025. It was officially spotted by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is actually a bunch of telescopes all around the world in places like Hawaii, Chile, and South Africa. What they do is stare at the night sky and look for moving objects. And that is what they saw on the night of July 1st. Just another moving object. So they classify it as a new asteroid and they're ready to move on. But then they notice something weird about this one. It's moving too fast. Everything in space is constantly in motion, and every object in the solar system rotates around the sun because we are all trapped by its force of gravity. The fact that we are moving is what keeps us from falling into the well of gravity. And the closer you get to the sun, the faster you have to move in order to stay afloat. But if you start to move fast enough, then you actually start to rise up out of the well. And if you reach a certain velocity, then you break free completely of the sun's gravity, and you can fly out into interstellar space. You enter the void of nothingness that exists between stars. And when astronomers clocked the velocity of this new asteroid, they were shocked. This was the fastest moving object ever detected in our solar system. Let's establish some scale here. The planet Earth orbits the sun at a speed of 30 kilometers. That's us. We're moving pretty fast and we're pretty close to the sun, but there are planets that are a lot closer. Here is Mercury, 0.4 astronomical units from the surface of the sun. It gets cooked, and to avoid falling into the gravity well, Mercury has to orbit at a velocity of around 48 kilometers. The new object discovered by Atlas was moving at 58 kilometers, and at the time it was still way out there just inside the orbit of Jupiter. That's about 4.5 AU away from the sun, and at that speed it was clear that this object was going to blow straight past the sun and just keep on going. We call this a hyperbolic trajectory. meaning that this thing had come from the void from interstellar space, and that's where it was going to return after completing its grand tour of our solar system. This is when the name 3E Atlas came to be. Third interstellar object, which means there were two before it. You probably know this one, Oumuamua, the first ever identified interstellar visitor. And it was also pretty weird, although it was weird in a totally different way than Atlas is, and we'll get deeper into that very soon. But we also have a second interstellar object, the often overlooked middle child to Eros, which was actually not that weird. Aside from the fact that it was interstellar, it basically just acted like a normal comet. So if anything, it was weirdly not weird. There are three big differences between 3 Atlas and its interstellar siblings. One is size. It's literally much bigger. Oumuamua was up to 400 men across. Borisov was as wide as 1 kilometer, but 3 Atlas could be up to 5.6 kilometers in width. 2 is speed. Atlas travels at about double the velocity of Oumuamua and Borisov. And 3 is the direction that the object came from. And this is the really weird one. Oumuamua came in from above from the northern sky, which is the general direction that the solar system is moving. So we are all orbiting the sun. But the sun itself is also orbiting around the center of the Milky Way galaxy, and it's dragging us along with it. So as much as Oumuamua hit us, we also kind of ran into it. 2 Borisov did mostly the same thing. It came in at more of a diagonal angle than straight on, but from the same general direction. Now, 3 Atlas is not another head-on collision. This one is a T-bone, and it's coming in on that side angle in almost perfect alignment with all of the planets. Our solar system is like a disk of stuff that all formed around the sun. Over time, all of that stuff kept smashing into each other and forming into planets and moons and asteroids and things, but it all remained in a relatively flat disk shape. We call that disk the plane of the ecliptic. There are only a few things that are a little bit offset from that plane. The most recognizable one would be Pluto. Its orbit is tilted by 17 degrees. So sometimes it's a little above the plane of the ecliptic and sometimes it's below. It's important to know that so we can appreciate how well-aligned 3I Atlas actually is. The interstellar object is only 3 degrees off from that ecliptic plane. It hit our solar system in perfect alignment with the disk. Space is 3-dimensional, and that object could have come from any direction. So to have something hit us almost perfectly side-on, it's a very big coincidence. But that leads us into an even bigger question. Where did 3 Atlas come from? Well, we know that it came from the direction of the galactic core. So if we look at the Milky Way galaxy from this usual top-down perspective, you are here in this kind of outer half of the galaxy located in a spiral arm. When you see the Milky Way in the night sky, that's the next spiral arm over. Anyway, 3I Atlas came from the direction of this bright core in the middle. It's bright because it's full of stars and they're packed together much more tightly than the ones in our neighborhood. But again, space is 3-dimensional, so to really understand where 3I Atlas originated, we need to flip the galaxy over to a side view. And just like our solar system, most of the stuff in the Milky Way is concentrated in a thin disk around the core. But also, like our solar system, there are a few things that kind of hang out above and below the thin disk. In the galaxy, we call that area the thick disk. It's a lot less crowded in the thick disk, so you don't get nearly as many giant collisions and supernova explosions and black holes and stuff. So things in this region tend to just hang out undisturbed for very long periods of time. And that's where astronomers believe 3I Atlas came from. This ancient region of space, which could make it as old as 7.66 billion years, nearly twice the age of our own planet. Now, we'll probably never be able to trace the journey of 3I Atlas all the way back to its point of origin, but astronomers have recently managed to backtrack over 10 million years, and they've identified 93 stars that the object would have encountered over that period. But what's deeply fascinating is that over the course of that 10 million years, the closest it would have come to any of those 93 other stars was a distance of 0.3 light-years. That's 63,000 astronomical units. And right now, 3I Atlas is just 1.4 AU away from our own sun. Now let's talk a little bit more about how 3I Atlas approached the sun, and what we learned about it along the way. Even though 3II Atlas was officially discovered on July 1st, it was actually spotted for the first time on May 7th, 2025. It showed up in images captured by the Transiting Exoplanet Survey Satellite, or TESS. It's an observatory that orbits the Earth and looks deep into the galaxy trying to identify new planets in other star systems. And for a period of about 1 month, TESS just happened to be looking in the direction of 3 Atlas. This gave us the opportunity to track the object as it moved through the orbit of Jupiter. The first thing that astronomers wanted to measure was the object's brightness and how it changed over time. That's going to tell us about what this thing is made of. We know that in the 1-month period that 3I Atlas was observed by TESS, it traveled about 1 AU in the direction of the Sun, so we would expect it to get brighter over that time. Astronomers use a term called flux to describe the perceived brightness of an object in space. Here's an example of how this works. Think about how bright the Sun appears from your location at noon on a clear day. Now imagine you're transported to the surface of Mercury. That same Sun is going to suddenly appear a whole lot brighter, bright enough to incinerate you. Now the actual brightness of the Sun didn't change, only your perception of it. That is flux. So astronomers had a hypothesis that the flux of 3I Atlas would increase by a factor of 1.5 between May and June. But data from tests showed that the flux actually increased by a factor of 5. So there was a massive increase in the amount of light being reflected by this object. And that's how we know that this isn't an asteroid. So it must be a comet that's beginning to form its coma of gas and dust, which is what's reflecting all of that excess light only. There are 2 weird things about this observation. One has to do with the polarization of light. Now, this is a tough one to explain, so we're going to oversimplify here. When light from the Sun hits that cloud of gas and dust around 3 Atlas, it's going to scatter in different directions. But the direction that the light bounces is not random. It can tell us a lot about the material that the light is hitting. If the light scatters off to the side at a right angle or perpendicular, then we call that positive polarization. If the light bounces straight back in a parallel direction, then we call that negative polarization. Most objects in space have a mostly positive polarization, even interstellar objects. 2I Borisov was positive, but 3 Atlas is negative. And not only that, it has the most extreme negative polarization of any object ever discovered. That is pretty weird. And it's just one of the many oddities about 3 Atlas that tells us not all solar systems are the same. What we think is normal here would be weird somewhere else. And what's normal in a different star system is considered weird around here. And then the second surprising thing about the coma of 3I Atlas was the fact that it even existed at all. Remember, we're looking at this period between May and June, and 3I Atlas is still way out there beyond the orbit of Jupiter. This is over 5 AU away from the Sun. It's cold out there. It's so cold that we don't typically spot comets at 5 AU, because they typically have not begun to form their coma yet. They're still frozen solid. It's not usually until somewhere between 3 and 4 AU that the sublimation process really kicks in. And that's because typical comets from our solar system are typically made of water ice, which needs a lot of energy to melt. But as we continued to observe 3 Atlas, and we started pointing our most powerful telescopes directly at it, we learned that the coma was actually dominated by CO2 gas. It did have some water vapor, but the ratio of CO2 was much higher at around 8:1. That's basically the opposite or inverse of what we are used to finding in comets. If you've ever seen dry ice before, it's typically used to create a smoky effect for live performances. That's frozen CO2. It has to be created and stored at incredibly cold temperatures. And as soon as it's removed from the deep freeze, dry ice will instantly begin to sublimate, making that signature cloud of gas. That is what 3I Atlas was doing way out there in space. And that's why its coma formed so early, because CO2 ice melts at a much lower temperature than water ice. And we've continued to observe 3 Atlas on its approach to the Sun. We've seen that ratio of CO2 and water begin to flip. By late in September, as it was passing through the orbit of Mars at just over 1.5 AU, the object had actually begun to release a massive amount of water vapor, about the equivalent of a fire hose running at full blast, which is actually more water than we would expect, even from a normal comet at this distance. We've never seen so much water vapor appear so suddenly. The same thing can be said for metal in the coma of 3I Atlas. When it was observed over the summer, Astronomers detected a small amount of nickel in the surrounding cloud, but they did not detect any iron. So a couple of things to note here. One is that nickel and iron are pretty common in the universe because they are formed inside the core of a dying star. Then that star goes supernova and blasts these metals out into the surrounding area of space where it gets pulled in by new stars that are beginning to form their own planetary disk. And then the process repeats. So because nickel and iron come from the same place, they're typically found together in planets, moons, asteroids, and comets. So when we see a lot of nickel but no iron, we wonder where the iron went. What process separated them? And thing number 2, it's weird to see any metal at all sublimating from 3I Atlas given its distance to the Sun when this observation was made. It's still way out beyond Mars in the region of the asteroid belt, which is still very cold, and the process of sublimation is driven by heat. Now, when it comes to CO2, we know that it doesn't need much heat in order to melt. But when we're talking about metal, there's something else going on. Likely the massive release of CO2 is dragging nickel atoms along with it. But that still doesn't account for the iron deficiency. Now, just like water vapor made a very sudden appearance in the coma of 3I Atlas, the same thing did eventually happen with iron. By late into September, astronomers had started to detect iron for the first time in the coma. And then very quickly, the ratio of nickel to iron changed to a more normal combination of the two. So 3D Atlas is becoming more normal over time, but it's getting there in a very strange way. Now let's talk about tails. This is another area where 3D Atlas has behaved a little different from your average comet. And that's mostly because the first time we saw a tail forming around 3D Atlas back in the summer, it was pointing in the wrong direction. This object initially formed a sun-facing tail. This is unusual because the tail is considered to be an effect of the solar wind interacting with the coma. The solar wind blows away from the sun, so therefore we expect the tail to flow in that direction. In this case, it didn't, which could be related to the early formation of the coma, which was due to the high CO2 concentration. Because the object began sublimating at a very long distance from the sun, it's possible that the solar wind just wasn't strong enough yet to push the cloud of gas and dust away. So, what we saw was more of that cloud accumulating on the warm side of the object, the sun-facing side, before it encountered a strong enough wind to form a conventional tail, which is what 3I Atlas eventually did. By September, a short fan-shaped tail facing away from the sun had developed, which is pretty normal. Not all comets have long streaking tails like what we're used to seeing in illustrations. The length of the tail varies according to what the comet is made of and its distance to the sun. For example, Hale-Bopp is pretty famous for having a gigantic tail when it was observed in 1997. But it was also very close to the sun at that time, about 0.9 AU, 1/2 of an AU closer than 3 Atlas will ever get to the sun. So of course it experienced more sublimation and solar wind which shaped that tail. And it's around this time that we actually get our closest possible observation of 3I Atlas. But the view doesn't come from the Earth. It comes from Mars. On October 3rd, the object passes within 0.19 AU of the planet Mars, the closest it will come to any planet in the solar system. And this is lucky for us because we have a lot of cameras on and around the red planet, which means we were able to use them to image 3 Atlas. Here is a photograph taken by the Perseverance rover from the surface of Mars. This is how the object would have appeared in the night sky. It's not a great picture. This isn't what the rover's camera was designed for. And in order to see this much light, the camera had to take 30-second long exposures. Then several of those images were stacked on top of each other. So what you end up with is more like a streak than a defined object. And here's another image of 3 Atlas taken by the European Space Eyes ExoMars probe, which hangs out in orbit around Mars. We can see the object a little more clearly now, but there's still not enough resolution to distinguish between the bright coma and the surface of the object itself. In order to get that fine detail, we would need to take a photo with NASA's Mars Reconnaissance Orbiter, which has the most powerful telescope in the Mars system. Unfortunately, at the time we are making this video, that image has not been released, if it was even taken at all. Basically, there's been a shutdown of the US government, and people at NASA aren't going to work until some political stuff gets resolved, which unfortunately could take some time. But time is something that we have right now, because the sun is going to continue blocking our view of 3 Atlas until early December, at which point we'll be able to study the effect that the sun had on the object, although the closest that we'll get is still 1 AU that happens on December 19th. At this point, 3I Atlas will be well on its way out of the solar system. But there is just one more close encounter still to come. On March 16, 2026, the object will fly within 0.36 AU of Jupiter. While we don't have nearly as many cameras around Jupiter as we do at Mars, we do have one. It's on a probe called Juno, which has spent the past decade observing the gas giant and its moons. But it will have a chance to take one last image of 3I Atlas before it disappears. Now at this distance, the object will be cooling down. It's going to be less active, but it could be changed by its exposure to the sun, and that will add an extra layer of understanding to these interstellar objects. It's entirely possible that a lot of these strange characteristics didn't even come from the place where the object was formed. It's just an accumulation of weird stuff that it picked up along the way. For now, we can only wonder, but more answers and probably more questions are soon to come.